Hello everyone and welcome to our science online class. We have a very exciting topic for today, so if you already have your course book, your pen and notes, we're going to start now. So I'm going to give you here some mind-boggling questions that are related to what will be our topic for today. So if you're ready, let's go. Question number 1. This is a halocarbon which is used for cooling system of ACs, and it also releases chlorofluorocarbon, which is bad for the atmosphere. What do you think is this? Time is up. The correct answer is freon. Question number 2. Look at the picture. What group do you think is this? The correct answer is it's lime. Next question. Look at the picture. What brand do you think is this? And the chemical name is sodium bicarbonate. So what is the common name of sodium bicarbonate? The correct answer is baking soda. Next question. What is the common name of the household name of calcium carbonate? Just look at the picture. It's very simple. What is it? The correct answer is it's chalk. So how many marks did you get? Did you get 4? If you get 4, you are really awesome. So what do you think is our topic for today? Our topic for today is all about reactions between acid and carbonates. And related to this reaction is the production of carbon dioxide. So we're going to take a look here on how to test for the carbon dioxide. So for your reference, you can open your coursebook on page 113. Our objectives for today is to analyze the process on how to test for the presence of carbon dioxide and also to determine the product of reaction between acids and carbonates. And we're also going to learn here how to write or to identify what will be the product of the reaction between acids and carbonates. Are you ready? Let's go. First is, let's identify first where we get carbon dioxide. So which of these 4 pictures here is related or associated with carbon dioxide? Same. Did you answer A? If you answer A, this needs carbon dioxide, but it releases oxygen, which is now being absorbed by letter C, but is releasing carbon dioxide. Letter B also produces carbon dioxide because of the combustion. It's usually evident on factories. But letter D, you might have seen this on social media. There are a fuel stocked on the frozen lake in the form of CH4, which is methane, which you then lit it up. It produces a burning phenomenon there, which releases carbon dioxide. So all of this actually is related to the production or presence of carbon dioxide. So definitely it's everywhere. I want you to look at A and C. These are very important process that we're going to take note and we're going to bring the concept as we go along. So what is a carbon dioxide? The carbon dioxide is simply a compound which contains carbon and oxygen. So the 2 red atoms you can see there are oxygen atoms, and the gray circle, the gray atom, and it is carbon. So 2 oxygen, 1 carbon, that makes it carbon dioxide. So how do we test for the presence of carbon dioxide. So we will be needing here a special kind of liquid in the form of lime water, otherwise known as CaOH2. And in this equation, we'll be producing calcium carbonate in the form of CaCO3. So lime water here, look at the color, it's clear. So we're going to start blowing air through the lime water using a glass straw, and take note of the change in color. So look at the color now. So we know that exhaled air contains carbon dioxide, which combines now with CaOH2, which is your lime water, and what we produce here is calcium carbonate. So look at what's the color. The color turns into, you got it right, it's milky white or cloudy because of the presence of carbon dioxide. So look at the picture here. This is before we put carbon dioxide and after we put carbon dioxide on the lime water. Notice on the change of color. So to test for the presence of carbon dioxide, what we need here is a lime water. In this setup, instead of blowing it, we use here green algae or those green small protists or photosynthetic plants which are found in the pond or in the water. So we put them here and they will be releasing carbon dioxide here, but you need to put them at night because in the morning they will release oxygen, but at night they will be releasing carbon dioxide. So the lime water here turns cloudy because of the presence of what compound? Very good. It is carbon dioxide. So since we're talking about carbon dioxide this time, let's talk about acid. What is an acid? Take a look with the chemical formula that I have here. Which of the formula here is an acid? Think. Did you answer A? If you answer A, you are right. But is A the only acid here? Exactly. A is not the only acid here because B is also an acid, it's nitric acid. C is an acid, it's sulfuric acid. And E is a carbonic acid. A, by the way, is hydrochloric acid. So how about D? What is D? Exactly. This is methane. The chemical formula is CH4 and this is usually used for fuel. So look on A, B, C, and E. How would you know that in a formula it's an acid? Exactly, because it contains hydrogen. We want you to take note of that. It contains hydrogen. And you're going to react it with a carbonate. So what is a carbonate? Simply, a carbonate is a compound which consists of carbon atom, the colored gray atom right at the top, combined or bonded with 3 oxygen atoms, that's the color red at the top, and it's usually negative charge. That means it tends to bond with a positively charged ions. So the ion here is a carbonate, negative, which will bond with an acid, which is a positive. So we will be using here a metal carbonate. So what's a metal carbonate? It's simply a carbonate with a carbon atom and 3 oxygen atoms, but it is bonded with a metal. Let's see some examples here. So in a reaction between carbonates and acid, we will be using here a metal carbonate. We have here calcium carbonate. Why this is a metal carbonate? Because, exactly, calcium here is the metal and it's bonded with the carbonate, so it's a metal carbonate, and it will be reacting with a hydrochloric acid. So, limestone is a calcium carbonate and hydrochloric acid is our acid. So it will form this salt crystals here in the form of calcium chloride, and the liquid which is found here forms into water, and the bubbles here are actually carbon dioxide. So you might be asking me, How do we form calcium chloride, water, carbon dioxide in this process? Let's take a look with the example here. So, for this discussion, we will be using the three compounds: hydrochloric acid, sulfuric acid, and nitric acid. Notice that we don't use carbonic acid on this process. Why? Because carbonic acid together with carbonates will form a different compound, and we will be discussing that in the future. But for now, we will be using these four acids. So let's have example number 1. So look at this. Sodium carbonate plus hydrochloric acid will produce 3 compounds. What are these compounds? First compound here is a kind of salt. So to write the product here, first we're going to get the metal. So which is the metal here? Obviously the metal here is the sodium from the sodium carbonate. So right here first is sodium. Next is we're going to react this sodium or bond the sodium with something from the hydrochloric acid. And what is that? Very good. It is the chloride. Why chloride? Because the hydrochloric acid contains the Cl here. So the sodium here will bind with the Cl. So therefore forming sodium chloride plus CO2 plus water. So wait, where do we get the carbon dioxide? Very good, we get it from the carbonate. The carbonate here is C and O, carbon and oxygen, which now forms into carbon dioxide, and also it will release water. So where do we get the H? Very good, we get the H here from the H and the HCl, or the H from the hydrochloric acid. So where do we get the other O? Exactly, we get this again from the carbonate, CO. That means we only do not have 2 oxygen here in the carbonate, but sometimes 3. That depends upon the chemical formula. So we release here carbon dioxide plus water. And we move on to the next question. Example number 2. We have here potassium carbonate plus sulfuric acid will give you what product? First, we're going to write potassium. It's the metal. Next, which part here of the sulfuric acid reacts or bonds with the potassium? Very good. It's the SO here in the sulfuric acid. So we will be writing here. Okay, we'll be writing here sulfate. So our next product here is potassium sulfate. And of course, plus carbon dioxide plus water. So we get the carbon dioxide from the carbonate, we get the H2O, the H from the H in the sulfuric acid, and oxygen from the carbonate. As simple as that. So let's take a look with number 3. Magnesium carbonate plus nitric acid will give you what compounds? First, we're going to write the name of the metal, and that is magnesium. So which part of the nitric acid will the magnesium bind to? Very good, it will bind with the NO. So what will be the name now of the compound here? If there's an NO. Very good, magnesium nitrate. Plus we get carbon dioxide from the carbonate and hydrogen from the nitric, H from the nitric acid, and oxygen from the carbonate. Therefore, our product will be carbon dioxide plus water. Notice that in all of the chemical reaction, we always release carbon dioxide and water.